So here we are, and we want to find the conditional distribution for these two hospitals. So let me go in here. Okay, and the way you do this is you're going to find it by finding, you're going by hospital. So in other words, by row. So you want to take the 790 and divide it by the row total right here. And give that dollar signs. That way when you drag the formula across, everything will be great. Then you do it again. So when they say by hospital, you have to say, okay, the hospital is the row variable, so I'm going to be working across rows. If they had said by living and dying, then you would have gone up and down the columns. All right, so there we go. Conditional distribution right here. Oops, my fault. Okay, so based on this conditional distribution, which hospital would you prefer to go to and why? Well, I think it's rather obvious. You'd prefer to go to county hospital because 90% of the patients live in county at that hospital. Whereas only 79% live at Mercy. Seems kind of simple, right? Well, that's where the tricky part comes in. You actually should pick Mercy. Now I'm going to show you why. Called Simpson's paradox. All right. So suppose we look at the data just a little bit more deeply, and we look at the percentage, the number of people that have been brought in fair condition or better, and poor condition or worse. All right. So we got fair condition or better. I'm going to copy and paste this into Excel. So right here. And then let me go back. Get the poor condition or worse right here. Over here. All right. So what percent lived out of this? And you say, okay, well, at Mercy, 580 out of the 590 total that they had lived. They had 590 admits in fair condition or better, which means 98% of their fair condition or better lived. What about the next hospital, county hospital? Let me drag it down. At county, only 96% of their fair condition or better lived. What about down here? Right, same deal. I'll just do it. Equals 210 divided by 410. So out of those that are admitted with poor condition or worse, 51% lived, whereas down here it's only 36% in county. Right? Notice this adds up, right? 86 plus 40, see those two? Those two, bad color. Those two would make 900, right? This works. These are the same numbers, right? And 580 plus 210 adds up to 790. Let me give it, I don't know, like purple. Right? Adds up to this 790 right here. See? So it works out. But look at the percentages. Mercy is higher in both of them. All right, I'm going to copy and paste these numbers in to, into YouTube where I'm posting these over here. All right. And then let me do it again. All right. So we filled in the 4 blanks. Compare the percentages in the first table with those in the next 2 tables. What's going on? So even though, I'm going to type this up. I'll be right back. Okay. Even though county has more people overall live, it's because county gets more patients that are in good and fair condition to begin with. I mean, if you're getting only, look at this, 890 good and fair patients, right? So the vast bulk of what county is getting are good and fair, whereas Mercy is getting only 590 good and fair. So this 96%, even though it's lower than the 98%, is winning out, right? Mercy gets so many poor patients. It does better with them, but it just gets so many of them that it overcomes their numbers. So it makes it seem at first glance like Mercy's worse. But in fact, county is worse. County does worse with both good and fair patients and with poor and worse patients. So which hospital would you pick? I would definitely pick Mercy. Okay. Because it has higher survival rates for both good and poor patients. Right? So you're seeing that the good and the poor patients is a lurking variable in those original numbers, and it makes it seem Mercy artificially low.